Exponential functions. Suppose that a laboratory experiment uses fruit flies that double in number every 5 days. If the initial population contains 100 flies, the number at any time t days into the experiment will be modeled by the function with the rule p of t equals 100 times 2 times 2t power. A. Find the average growth rate of the population from 0 to 20 days. So we just took 0 days and found that there were 100 flies in 20 days, and there were 1,600 flies. So 1,600 minus 100 over 20 minus 0, and we got 75 flies per day. And we all got that by graphing it and then put it in the calculator and then just putting it on our paper. B. Estimate the rate at which the fly population will be growing at day 0, on day 10, and on day 20. So this is 0 to 10, and then 10 to 20. And for the first part, it was 30 flies per day, and the second part, about 120 flies per day. C. Find the average growth rate of the population from day 20 to day 40. So right here is C. So on day 20, there were about 1,600, and on day 40, there were about 25,600, which ended up being 1,200 flies per day between that period. Estimate the rates at which the fly population will be growing on day 20, day 30, and on day 40. So here's day 20 through 30, and day 30 through 40. Trigonometric functions. Okay. Suppose the water depth at a given tidal harbor is given by the trigonometric function with the rule d of t equals 9 sine point by t plus 15. Depth is in feet and time is in hours. Use radian measures. A. Based on your knowledge of sine function, what overall pattern of change would you expect in water depth from 0 is less than t and t is less than 24? The water will rise and decrease at the same place, and it will always start from the same depth. That's what we put on the graph right there. B. Use the function rule to calculate the water depth when t equals 0, 3, 6, 9, and 12. So we just took these points and put them onto a table from the graph, and we got the graph from the function that we put into our calculator. C. Use the information from part B to calculate the average rate of change in water depth in the following time intervals. So it's basically 0 to 3, 3 to 6,